All right, let's go ahead and jump into lesson 14 in this session. Lesson 14 is going to deal a lot with trigonometry. It's going to deal with sine, cosine, and tangent. You remember for your formula page, sine is opposite over hypotenuse. So if we're taking from angle 36, the sine of angle 36 is going to be opposite b over hypotenuse 6. Cosine is adjacent over hypotenuse, so if we're taking it from angle 36, cosine of angle 36 is adjacent a over hypotenuse 6, and if we were finding the tangent, which is opposite over adjacent, it would be the tan of 36 is b over a. Now obviously we're not going to do this one because it would give us two variables and we cannot solve for this one. Now on sine of 36, the way to solve for this, you multiply both sides times 6. B is sine, you put in your calculator 6 sine 36. So the answer to B in this one is 3.52. Same thing with this one, you're going to multiply both sides times 6, so you get 6 cosine 36, and the answer to A is 4.85. So that is how you solve for the missing parts. Now the only way that you can use sine, cosine, and tangent is if it is a right triangle. Because it's a right triangle, you can use these in order to solve for this. There are other ways to solve for missing parts in a triangle when it's not a right triangle. We'll get into that a little bit further in the book. The next we're going to look at is example 14.3. And it's the same thing. It's trigonometry, sine, cosine, and tangent. It's going to be in a word problem form. We're going to do angle of depression and angle of elevation. The first one is angle of elevation, and they're going to say a man, and I'll read it to you. It just says a man 6 feet tall is 200 feet from a tree, and he measures the angle of elevation to the top of a tree. So a man 6 feet tall measures the angle of elevation to the top of a tree. You got a beautiful tree here. There's his angle of elevation here. And he is 6 feet tall. It says it's 11 degrees. He's 200 feet from the tree. And it's an 11 degrees angle of elevation. And so what they want to know is how tall is the tree. So the first thing that we are going to solve for is this right angle here. So we want to know how tall this is. And so we're going to do from 11 degrees, we're going to do adjacent, we're going to do opposite and adjacent. So tan of 11 degrees equals opposite x over 200. Multiply both sides times 200, and you get x equals 38.88 feet. Now that's not the height of the tree because the man was 6 foot tall straight on. So you got to go 6 foot plus this. So the answer ends up being 44.88 feet tall from the ground to the top of the tree. The next one is example 44.4. It says an airplane is flying at an altitude of 3,000 feet. And so that was angle of elevation, which means up. Angle of depression, we're going to have an airplane here. And it's going to be looking down at an object. Now the angle of depression is going to be this angle here. Well, that's not going to be the angle that we need. So they say the angle of depression is 26 degrees. and it's 3,000 feet above the ground. This is 26 degrees. 3,000 feet above the ground. They want to know how far it is from the plane to the object on the ground. And the way that you solve for that, so when you're finding the slant height, the first thing you're going to have to do is you take this like a 90-degree angle. And so this angle that we actually need is going to be the complement of angle 26. And so we get 64 degrees. So from 64 degrees, they want to know the slant height, which is actually going to be the hypotenuse. So we're going to use cosine of 64 degrees equals 3,000, which is adjacent, over hypotenuse. Once again, we have to isolate h, so we're going to multiply both sides times h. 3,000 equals h cosine 64. H is still not isolated. We got it from the denominator to the numerator, which is great. Divide both sides by cosine 64. H equals 3,000 divided by cosine 64, and that's going to be 6,843.52 feet. That is the slant height of that. So the only tricky part about this is to remember angle depression, you got to get the complement to find the angle you need in order to solve for the missing parts. Just a little trig review. The last part of lesson 14 is going to deal with the coordinate plane. And you have first quadrant, second quadrant, third quadrant, and fourth quadrant. And the signs in the first quadrant are positive, positive. The signs in the second quadrant is positive, negative. Third quadrant is negative, negative. Fourth quadrant is negative, positive. This is our 0 degree, or it's 360 when it comes back around. You're going to start here and go this way for positive. This is 90 degrees. This is going to be 180 degrees. And this is going to be 270 degrees. And anytime you name an angle, if it's named in the first quadrant, this angle right here, you start here and you go to the radius, so it's going to be as is in the first quadrant. Second quadrant, you are going to subtract 180 if this is our angle, and you actually need from here to here, you're going to need this as your angle. So you're actually going to take whatever the angle is, let's say it's 60, subtract from 180, so 120 would be our angle. In third quadrant, let's say our angle is 60 here, but you need to know from here all the way to there, so you're actually going to add 180 to the angle that you have. If it was 60, then it would be 230. And in the fourth quadrant, it's going to go all the way around to here. So if your angle was 60, you would actually subtract 360 from your angle in order to come up and name your angles. So you can name things in different ways. Now what we're going to do, the last thing we're going to look at is changing from polar to rectangular or rectangular to polar. First we're going to look at is going from rectangular to polar. Negative 3i plus 2j, this is called rectangular coordinates. And the way that you would graph this on your coordinate plane is just like, this is just like x comma y. Or I think last year you did it as r and u. So it would probably been negative 3r plus 2u. That's what it would have looked at last year in your Algebra 2 book. So if you are labeling this, remember we said positive, 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 negative, 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 positive. So this is, oh, I think I did that backward, because this should be negative, positive. I don't remember if we did that backward or not. This one should be positive, negative. Whoops. But it's going to be negative 3i and then 2j. This is actually a second quadrant problem here. And so your 3 is here, your 2 is here, and what you're solving for is the radius and the theta. The cool thing is you can use your calculator. In your calculator, it's going to be, you're going to use the angle button, so it's second function apps. It's going to be above your apps button on your calculator, so it's second function that. When you scroll down, you're going to look for this right here in this particular problem. You're going to look for rectangular to polar, or R arrow P, and the little r, which stands for radius, and the theta stands for the angle. So you're going to use the R to P R. So in your calculator, you're going to put -3, 2 after you press this button. And when you hit enter, what you're going to get for the radius is √13. Now you may get a decimal, and so that's fine. √13, √13. But what they want is they actually want 4 answers for these. And so it's going to be 2 positive radius and 2 negative, because you can name something on the coordinate plane in 4 ways. Obviously, the positive √13 is going to be there in the second quadrant. But whenever you press the button and solve for this, you're going to get 146.31. And so whenever you press second function apps, R to P theta, you get 146.31, and that's going to be from here to here. Now, the way to label that negative is to start here and go all the way around. And that's going to be your second way, is √13 with a negative angle. So every deal has a positive and a negative angle. The way to do the negative is to take 146.31 and subtract it from 360, and that's going to give you the opposite coordinate, which is going to be -213.69. And that is right here. And that's named here, but it's the same spot. Now the other way to name this is to give it a negative radius. When you give something a negative radius, you simply move it from here to here. It becomes -√13. Now, in order to know what your angle is, you got to know what your angle was inside your triangle there. And your angle inside your triangle was 33.69. And whenever you take 146, remember how to solve for an angle in the second quadrant. It's 180 minus 146.31. And you subtract that out, you end up getting 33.69. So when you bring that over here, it's still 33.69. And what I would do is I would go ahead and do the negative version of this first, because it's going to be -33.69. That's not difficult to see, because a negative starts here and ends here. So it's the angle that it's as is in the fourth quadrant for negatives. Then you just add 360 to this to get your fourth angle, which is 326.31. So that is your way to change something from rectangular to polar coordinates by putting -3, 2 into both of these buttons, same numbers into just 2 different buttons. It gave us the radius and it gave us the angle. Once we found one radius and one angle, we could then fill in the rest. We just simply named the same thing 4 different ways on how to solve for this. If you have any questions, we'll look at these more in class. The last thing we're going to look at in lesson 14 is taking something from polar to rectangular. So the example that we're looking at is on page 112, example 14.6, and it gave us -13 and -253 degrees, and they want to change it from polar, this is polar form, to rectangular form. So you're going to go once again in your calculator to second function apps, which should be the angle button, and you'll scroll down looking for the P to RX and the P to RY. Now the X is the same thing as solving for I and J. And that's what we're going to put it in. And so you're simply going to put negative 13, comma, negative 253 degrees. So you press second apps, P to R, X, and you're going to put that in. And when you do that, it is going to give you the I and then the J when we do it again. But for the I, it's going to give you 3.80 I. Plug the other one in, and it's going to give you negative 12.43 J. And this one's a whole lot easier. You don't have all this other kind of stuff. But you simply plug in these two numbers into these buttons. You get your X and your Y, which is your I and your J. So polar rectangular, a whole lot more fun, a whole lot easier to do.